Hey everyone, welcome back to the 443 Security Simplified. I'm your host, Mark the Liberty, and joining me today is...
Corey Vibecoder Knockreiner.
On today's episode, we will cover an FBI alert on file converters delivering malware. After that, we'll go into a deep dive on browser cache smuggling as a mechanism for delivering malware to an endpoint. And we will end with a report from Wiz on a cascading supply chain attack affecting Github actions. With that, let's vibe our way in. So let's start this week, Corey, with a alert that the FBI Denver office published about a week ago. It's not super in-depth or not super technical, but it's another interesting attack path that I thought was worthy of talking about. So basically, the FBI published an alert saying that cyber criminals are creating free online document converter tools to load malware onto victims' computers, and in some cases, even leading to ransomware. And I don't know about you, Corey, but after seeing the headline, my first thought was like, no duh. Like, of course they're doing that. This feels like a prime avenue for delivering either straight up malware or at least booby trap files. But I guess it's been a trend that's been increasing, or at least the FBI has been getting a increasing number of reports through their ic3.org or ic3.gov site. So the converters, they all claim to convert like similar file types, like a JPEG into a PDF or a document into a PDF or whatever. Some of them even offer to download MP3s or MP4s from online media sources. It's like a YouTube downloader, for example. But the tools, most of them actually work as advertised. Like they will convert your document into a PDF and like an actually readable PDF. But the resulting files sometimes contain hidden malware that can be used to gain remote access to the victim's computer. Meanwhile, they're also scraping any information out of the files you upload, looking for things like PII or banking or cryptocurrency info, email addresses, passwords, other credentials to steal that and use against you if you've got that in your Word doc or your picture or whatever. The tools are all hosted on legitimate looking URLs that are designed to mirror like legitimate brands or services. They noted like for some examples, they just changed like a blah, blah, blah incorporated to a blah, blah, blah company, for example. And most notably, or not most notably, but also notably, they're also using paid search results on Google to boost theirs to the very top of your search feed. As you know, like Google, when you search something, the top, what is it, like 10 posts now is what it feels like, are all advertisements instead of the actual natural search order. So if you pay a bit of money, someone searches for free online file converter, you could get yours pumped into the top of the list. So like a couple things, like first off, Corey, question for you. Like, I've got a couple ideas, but I'm curious, how do you think that they're embedding malware into these files? Like, imagine converting a doc to a PDF or maybe a PDF back to a doc. Like,
I mean, it seems pretty trivial. PDFs allow you to add all kinds of things like links and active scripts. We know Word documents allow macros and other active content. So I assume they're just properly converting a document, but then based on the type of document, they're leveraging the same old tricks that a normal Word document might be embedded with a malicious script, or a PDF might be embedded with bad links or scripts. Yep. Now, 90%, like there could be a chance that they're even exploiting exploiting vulnerabilities. A lot of those have been patched, though, so I think it's more likely they do something that requires some sort of user interaction, like enabling scripting or enabling active content. But I assume they're just adding a bit of ActiveX or JavaScript to these documents after the conversion.
Yeah, that's what I suspect as well, too. Another thing that stood out to me is like this whole alert came because the Denver field office, which I guess handles this specific type of like cybercrime, so they were getting an increasing number of IC3 reports on it. And the first thing that stood out to me is, oh, they're actually reading those.
Yeah,
Because I
thank
know we get
goodness.
like macro level results from them. Like they put out a good report every year with like high level trends and like ransomware payments or business email compromise fraud, things like that. But I always, so
I
I've been to
assume
a few
hundreds
like,
of thousands of consumers might have posted something before, and I don't imagine them responding in that
yeah,
amount
because
to all of those reports.
our listeners may not have ever filled out an IC3 report, but like one of the questions they ask is like, what is the dollar amount that you lost in this? Because it is a way to report like fraud where you actually had like monetary theft against you. And in some of the like speaking engagements I've been at in the last couple of years, there's been a few where like there was an
5,000.
FBI agent there, and they were pretty candid in saying if you put down like anything less than like 10 grand or 20 grand, like we're sorry, but we probably don't have the resources to go help you with that. But if it is something larger, we absolutely will come and help you. I interpreted that as they probably don't even read the other ones, but it seems like they are at least like reading these other ones if they're finding these trends. So that was interesting.
And then, by the way, they're probably not resourced the same this past 3 months, so they'll probably read even less. Uh, I don't dislike the FBI. Like we're friends with the FBI based on incidents, but I do remember one complaint we had is while it was a weird IC3 report, we had a period of time where we knew our customers were being targeted by an attack. It did not affect us directly at all. It wasn't to our company. It was just to devices that customers had out there. And we created an IC3 report based on it. And later on, there was a security incident that perhaps wasn't related, but at least we you kind of assumed the FBI might have connected the dots between something they knew was happening and that report, and it was never connected. So that was when I realized that I like that we have them. I mean, the FBI is supposed to be where you report cybercrime right now. You can try your local police, but they don't always have a cybercrime organization. First time I realized that you may not really get much response, which is not entirely their fault, but it does kind of suck that a normal consumer can be hacked and doesn't have much recourse of where they get to go.
Local police is an interesting one. I'm imagining like someone in Manhattan, Kansas, like going to their local police and reporting a cybercrime and like
They'll be like, "What?"
what level of resources. And this isn't to say like anything about like the intellectual capabilities of police in Manhattan, Kansas. I'm just assuming they don't have any actual
Resource.
cybercrime experts resources
Yeah.
on staff.
It seems like the thing that's still like they have to know a bit about cybercrime now, but it's still something that I don't think they're as well trained on.
Yeah.
Either way, this is interesting. The like to be honest, luckily I don't do document consumer converters because working for a corporation, I have plenty of legitimate copies of things like Adobe Acrobat and Word that can convert all kinds of ways for me. But video converting and video downloaders, that's like everyone probably has wanted that one time or another, and the quickest way is to try to find a free online version. And it really is kind of a nefarious social engineering technique to offer a quote unquote free service. So as much as people are looking for those, I recommend you avoid them like the plague. Anything that's free nowadays, the billionaires don't believe in free, so don't trust them. And
And I
don't
liked
trust the attackers that take advantage of it either.
agreed. I just assume that any free online converter is probably going to result in something I don't want on my computer, which is why I'm even more upset about what was it, YouTube DL, the GitHub project getting taken down. And I
The
think
one legitimate one that worked.
yeah, the one legitimate one that worked. And I think they even faced like legal um, issues with that one too, the author of it. When it comes to this alert from the FBI, they had a really good bit of non technical advice that I think everyone needs to follow. It was take a breath, slow down, and think, and be aware of your actions online and the risks you could be exposed to. And I think that is probably the single best bit of advice you could give anyone in the world of IT or anyone working in
I mean,
IT.
it's
Like a
so
lot of
old
the
that people roll their eyes, but think before you click is something
yep,
that I remember being a campaign 15, 20 years ago. And people, I feel like with link shorteners, with smartphones, and with TikTok, despite us saying think before you click for 20 years, people are thinking less and less between clicks.
It does seem that way. And I guess
But
if
it
you
is
are
good
looking for,
advice, by the way.
correct,
We should be thinking before we click.
just be aware that anything for free, there's no such thing as a free lunch. They're getting paid somehow. And so try and be mindful of how they're potentially making their money out of that, whether it be scraping your info from your docs or delivering malware to your computer. It could be one of those.
I miss
Moving
the old
on,
days where they just installed some irritating piece of software I didn't want, but it was at least not malware.
like the old
The 30-day
advertising.
trial of
Yeah.
some antivirus that would start nagging me to pay in 30 days.
Yep. Yeah. Wasn't that nice? The age before ransomware.
Yeah. I
Anyways,
only got irritating marketing pups.
moving on. The second post that was kind of interesting. So this was from a red team researcher, Aurélien Chalot. I think they're French, and I think I totally just butchered both their first and last name. Where actually last year they published a really interesting post about weaponizing they called browser cache smuggling. They just published an update to that with some new techniques to help with that browser cache smuggling style of attack. But before we jump into their new post, like real quick overview of what browser cache smuggling is. So modern web browsers like Chrome or Firefox, they've got mechanisms for caching static files like images or videos, CSS scripts, JavaScript, whatever, and saving them locally so that if you refresh the page, your browser doesn't have to waste resources or bandwidth to go download them again. In Firefox, for example, there's a directory in your app data/local directory where all these cached files are saved. Most browsers automatically download and cache anything that is JavaScript or CSS. It's just by default. They'll go download it and save it to your computer. And this means for a red teamer, like Aurélien, this is a great mechanism for downloading any arbitrary file if you can trick the browser into thinking that it is a JavaScript file, an image, or a CSS script. So if you control the web server that the browser is connecting to, you actually get to control what the content type header is for any file that gets downloaded. So for example, you could host a library, a .dll file, but say that the content type is image/JPEG. And so when the browser goes to download it, it thinks that it's a JPEG image, even though it ends in .dll. And that will cause it to cache it and save it as a file locally. Obviously, like the image that it's trying to load would fail to load. They gave an example of like setting calc.dll as the source for an image in an HTML file. That would fail to load, but if you're not looking at DevTools, you wouldn't even see like the missing image element. But your browser behind the scenes downloaded that library file, that DLL. The cached files, they're not just like raw libraries. They also include like HTTP metadata, like HTTP headers in there. So he actually found a way to like search through these cache files and find the specific one you're looking for. If you see Corey's screen, like all of them, they ended up as like, I think it's a SHA-1 or SHA-256 hash of the file as the file name with no extension. So you can't just like look for calc.dll or ransomware.dll. You have to find a way to search for it. So he found that he could also, through his malicious web server, set a header in the HTTP response, call it like tag equals payload here. And then he could run a search script to go look for that cached file with a tag in there that says DLL here or payload here, and then load it up and execute it. So basically, like the original scenario he described in his first post last year was as like a red teamer or an attacker, you would first need to have the target like run PowerShell in order to go search for this file that got cached. PowerShell would then have to use the run DLL32 executable in order to launch the library. That would then spawn a process called SI host to spawn the payload. And that child payload would ultimately like communicate out over the network as a command and control beacon. So all four of those things, they're like giant red flags for any EDR tool worth its salt. Like if you see PowerShell launching run DLL32, that's a major red flag. If you see a PowerShell child process spawning SI host and then loading a payload, That's a major red flag. So all of these are like OPSEC issues that make this difficult to use in a real world scenario as an attacker or a red teamer. So the update he gave just this last week was a clever way to like get around some of those red flags, or at least mask the activity, by using Teams and OneDrive. And he picked them because they're both widely used. Like most organizations use Teams or OneDrive, or likely both. And both of them communicate over HTTPS, which means it's difficult for a defensive tool to see what's going on inside that communication. So the way this works is older versions of Teams and OneDrive, they get installed in the user's local app data directory, which means by default, the standard user has full read-write permissions in that directory. They can modify whatever files they want in there. Also, when Teams launches, it loads up a bunch of libraries that it needs to do its various actions. Some of them come included with it. Some of them are like Windows standard libraries that are included in C, Windows, System 32, whatever. But when it goes to look for a library, it uses the default Windows search order, which means it starts by looking in its local directory where it's installed. Then it looks at C Windows, System 32, C Windows System, whatever. So basically, if you can take a malicious library, a malicious DLL, get it to have the correct name, set it with the correct like export functions that Teams is looking for in that library, and then place it in its install directory because you have full read-write access in there. When the victim goes to launch Teams, Teams will automatically load that malicious library and start executing it through its normal functionality. He took it a step further. It gets even more complex, where he built basically this library proxy where Teams would load this proxy library. It would proxy the legitimate commands or legitimate functions to the real library version, so Teams continues to work. But it would also execute the malicious payload that it has either embedded in it or saved somewhere else, so that the attacker could gain access to the system. So basically, this new attack path is, first, you either trick the victim into browsing to an attacker-controlled website, or if you have access to the computer, you browse to the website using browser cache smuggling that downloads your cached library file locally. At this point, it's a file in the browser cache. Your PowerShell script, instead of needing to execute it itself, all it does is it looks for that library and copies it to the Teams directory and renames it. So now your red flag of PowerShell using run DLL32, that's gone. It's not actually executing the library. All it is PowerShell copying and renaming a file, which on its own, it's not super sketchy looking. Then when the victim launches Teams the next time, that library will get loaded up and executed by Teams itself. So now your second red flag is just Teams loading a library. That's not sketchy on its own. And then Teams and its child process issuing a network connection as that library beacons out. Like Teams makes network connections all the time. So this is a way to evade a lot of EDR capabilities that otherwise would have been giant red flags with that original browser cache smuggling attack. I thought this was super interesting. And he gave a few ideas of how to protect against this. For example, like Chrome actually has a registry key called Chrome Clear Browsing Data on Exit Lists, which, as you might guess from the name, it's a list of types of browsing data in Chrome to clear when you exit the browser. So you can even set this to like clear out the cache from Chrome anytime you close it. That's one potential mitigation for this. But like,
by the way, it's a good mitigation, but it's also an inconvenience. I mean, the benefit of that cache is you probably don't have to re-authenticate or re-show status sometimes on pages or re-get stuff so if you're used to just having Facebook open all the time and or some other web app like that, it might reset everything for you every time you close your browser, which is a good security, but people are used to that. Cache is making things faster and easier 90% of the time.
I think like some like silver lining or like good news for this, I don't think this is a type of attack path that'll be like widely weaponized against random organizations. This definitely feels like more of an APT style of attack, where They're taking extra lengths to really try and evade detection, and or like part of red teaming. This isn't like the type of thing I'd expect weaponized against random organizations all the time out there, because it does still take some level of effort from the attacker. But I thought, like, so you and I are obviously big advocates for like EDR capabilities as the post execution way of detecting threats and preventing them on an endpoint. And these are some really uh, powerful tactics for evading some of the main things that EDR tools would look for. Like EPDR, for example, it has a specific rule to look for PowerShell
PowerShell.
using run DLL32. And this type of attack
But
would at least prevent that
skip
one
it.
from.
Yeah, yeah.
Exactly.
You wouldn't see that because it wouldn't do it.
Exactly. So pretty interesting. It also shows like why folder permissions are so important, and why like executable installation directories should be separate from like user data directories where the dynamic content is written to as you're using an application. It's also why like newer versions of Teams are installed in your program files directory, which is
Program
rate
data.
protected in most cases versus the app data directory. But
I think it's
yeah,
program data now. It used to be program files. I was so
there we go.
irritated when they changed all the names of those. Now I have to go. And it makes it worse that if you have legacy apps, you'll have both program data and program files on the same Windows 11 computer.
Yep.
Because not every it, and I agree. This is important for software developers, though. Like having a user realize that their own user directory is always writable by them, but there's some limitations to every other directory. Like it changes what directory is writable or not by default is all under Microsoft's control at different times, and I like when they're keeping track of it, but it's not something a user can really keep track of. It's something
Yeah.
the developers have to. And maybe this is a call out to OS manufacturers. If you keep on freaking changing the name of program files to program data or whatever, and now you have all these like you're not making it easier for developers to follow the right security practices by making all kinds of stupid changes all the time.
This is why everyone should just use Mac OS, because it doesn't get malware.
Their OS maker that screws up all the time too.
What? No, Apple's the like shining example of perfection.
No, they do some things okay. They're definitely not perfection. And I don't think they really care further than the dollar you pay them.
That is 100% accurate, I think, too. So moving on to the last story. This one, there's a lot of moving pieces in here, so I hope I'll be able to do it justice. But I remember I saw this pop up like right before I started my vacation last week. And by the time I ended my vacation, there was like quite a bit of updates to it too. But basically, 2 weeks ago, Wiz, the cloud security company that was just acquired by Google for like an insane amount of money,
Billions.
yeah, published a post detailing a GitHub Actions supply chain attack that was designed to leak credentials from repositories that used a specific GitHub action called tj-actions/changed files. So before we get into that, like the details of this, real quick for GitHub Actions, it's like an automation workflow that developers can use in their GitHub repositories. Like, for example, in the security operations team at WatchGuard, we have a GitHub action that triggers whenever someone makes a pull request. So they want to merge in their code into one of our existing repositories. The action is designed to go like review the source code, make sure it passes all formatting and syntax checks before those changes can be merged in, just to make sure that our code stays clean. We have another one that like automatically deploys changes that are made into the main branch of some of our repositories into our production application environment in AWS. That action is even more complex. It needs to get credentials from a secret store, authenticate to AWS with a service account, and then deploy that action up to AWS. So there's a lot of moving pieces. And because they can get complex, developers often use third-party GitHub Actions. So for example, that AWS one, we have one written by Amazon themselves called configure-aws-credentials that just with a couple lines instead of 100 lines lets us authenticate excuse me, to AWS to deploy our code. So Some actions will use like API keys or GitHub personal action tokens, which are basically GitHub API keys, in order to do various actions. So if you can insert malicious code into an action that's used by a repository's workflow, you might be able to leak those keys and then use them to compromise that repository. Because oftentimes some of these actions need write permissions into the repo they're working in. So in a supply chain attack, like in this one that they described, someone modified a popular third-party action, and this started with a different one than even the ones Corey's showing, called it was developed by TJ Actions. The action name was changed files, and it's basically like a change log for pull requests. So they modified that to insert malicious code that downloads a memory dump Python script from another GitHub repository, executes it while searching for secrets, and then prints the results using base64 encoded to the workflow log. So basically, if this was a public repository and the action executes, the attacker could just look in the logs and see all of the secrets that were used by that workflow, any API keys, any personal access tokens, really anything that it potentially had access to. The attacker originally targeted a specific company with this as an end result. In one of the updates Wiz posted, they confirmed that the whole goal of this was actually to go after Coinbase and a repository that Coinbase had. So the attackers unsuccessfully tried to compromise the Coinbase agent kit repository by triggering an action in that repository after compromising the changed files action that it used. But the other interesting update is this actually didn't start with just TJ Actions changed files. It started with another action called action setup by a developer called ReviewDog or Reviewed D log. So basically, there's a whole timeline of events for this. And if Corey, you scroll down a little bit in here, you can see the whole thing. So this started with the attackers compromising a contributor to the review D log action setup action. And on March 11th, they poisoned a tag. So basically, when you use a GitHub action, you point to a specific tag, usually like a version number, like version 1, version 2, version 3, whatever, in order to choose which action to use. So the attackers injected their malicious code into what the V1 tag was pointing at for this action setup one, using a compromised contributor account. Within an hour and a half, they actually reverted that on the original one, which Wiz went ahead and suspected, I think accurately, that the attackers reverted it because they got their goal, which was a personal access token to the changed files action. So then they went and modified the changed files action and inserted their malicious code. And it stayed in there for about like a day and a half, I think, before they attempted to poison all of the tags associated with it. At some point, Coinbase's agent kit actually executed the malicious version of that change files action. It's possible it leaked a token with write permissions, but within 30 minutes, it looked like, or about an hour and 20 minutes, Coinbase removed the vulnerable workflow entirely from their source. And then within a couple of hours, the cat was let out of the bag for this. And a couple of different sources, including Wiz and another, I think it was Step Security, disclosed this supply chain attack. So like, long story short, like someone was going after Coinbase and a few other cryptocurrency adjacent repositories. In order to do that, they targeted a GitHub action that all of them used. And in order to get that action, they actually targeted one that action used. So it was a cascading supply chain attack of going after this small component, which got them access to the slightly bigger component, which then almost got them access to these really critical or important repositories. Good news is it doesn't look like they actually succeeded in compromising Coinbase or any others, but this is another one that very well could have. It was in my opinion, pretty well designed and executed, including cleaning up after themselves, attack that had a decent amount of success, even if they didn't get their final objectives on actions. I don't know. What's your hot take, Corey?
I, I think this is going to get worse and worse. We've talked about supply chain attacks and we've talked about repository, but the reality is people write less and less of the code they use. Like, no one wants to reinvent the wheel. The beauty of GitHub and public code and public repositories is there's almost always a function or dynamic library or snippet of code that already does the thing you want. And you're mostly like, no one uses their own code. And by the way, AI coding will make this worse because AI really isn't coding. It's going out and using known snippets of code too. So the fact that when we use pieces of code here and there or functions from 12 different repositories or 12 different open source things, it's not, or in for GitHub, this is automation. This isn't even the code for the thing we're making. This is probably automation for maintaining our own code, but it makes sense that when you have all of these dependencies on little actions that everyone is sharing and not many people are paying attention to, this this is going to happen more and more, and it's almost surprising that we can find it because it's buried so deep. It makes me think of XY utils too, and one of our predictions being people are going to take the long con and really spend a lot of time infiltrating little weird pieces of code snippets that the normal person, even the programmer, probably doesn't think about 99% of the time. And if they can quietly infiltrate that and do that, it's crazy how ubiquitous some of these code snippets or actions in the case of GitHub, or, you know, I'm sure every framework has its type of thing that it does over and over that people just use the thing. So
I,
it's scary to me. It is definitely a place where we'll see a lot of supply chain things.
I think there's actually a fundamental flaw in GitHub Actions that needs to get fixed. And I think it is fixable. It's just, it's going to totally disrupt how GitHub Actions work currently. So, Corey, I know you probably haven't played around a whole lot with GitHub Actions yourself. Basically, how they work, like, and to our listeners too, hopefully some people understand the concept of like a commit within a GitHub repository. So, a commit is like a point in time in the repository of what the code is at that point in time. So when I like say right when I change a file to update like a comment in it, I had to save it back to the repository. That's a commit back to the repository. In GitHub, you can add tags pointing to commits. So I can create a tag that says Mark's favorite update and point it to a very specific commit, which is basically what the repository looked like at that point in time. I could create a tag that says V1 and point it to a commit, or a tag that says V2 and point it to a commit. These tags are actually what GitHub Actions reference. So when I say I want to use the AWS configure credentials action, I actually am saying I want to use the AWS configure credentials action version 1. So I'm pointing to the tag that says version 1 for that. Because I know like sometimes there's breaking changes. I need to make sure my action will continue to work over time. So I point to that V1 tag. The problem is like, even if we take the time as developers to go, and I say we very generously here, I'm not a developer, I just pretend I am. But if we take the time to go review all of these actions that we're using before we start using them, and I know that like V1 of AWS configure credentials is okay and clean, the problem is tags are not immutable. You can go and update a tag to point to a different commit at any point that you want. And so from now on, V1, instead of pointing to the code I thought it did, could point to something else entirely within that repository. And that's what the attacker was doing. They went back and like updated the V1 tag to point to their new commit that they just did a couple of minutes ago with the malicious code in there, instead of like the old V1 that may have been like 2 years ago. So like the fundamental flaw in GitHub Actions is that they're not immutable. Like you can point to a specific one, but that specific one can change at any point in time. So even if it is safe right now, it may not be safe tomorrow. And one thing I think GitHub has to do is make actions immutable. And that's might be difficult. Like GitHub, just naturally you can change tags. They have to find some other system
On the
other
flip
than
side,
their
though,
built-in tags.
one of the things that allowed this is at least you, the owner of the automation or the code should be the only one that's pointing tags to things. Other people
It's
shouldn't
controlled by
have
the
privilege
action
to.
itself. So when I say I point at like AWS configure credentials v1, AWS controls which commit is v1 in there. So AWS, someone that compromised their
What I'm
account,
getting at,
could
that's
change
what
that
I'm
tag.
getting at, though. Someone did have to compromise a privileged account in order to do that. Maybe
Mm-hmm.
not to change the tag, but change the thing it was pointing to.
Mm-hmm.
So you do still have to own the project. So I guess another thing is that we just have to make sure there's no easy way for people to compromise your credentials, MFA, whatever.
So as a maintainer of an action, yes. But for like me, like we we could we could be the victim of this if no one at WatchGuard was compromised. We're entirely
Yeah,
reliant on the actions that
the
we're using
the
not getting
repository
compromised.
maintainer, the person
Yeah.
that owns whatever thing we're doing, whether it's an AWS, GitHub, wherever.
So like alternatively, if we pointed to a specific commit hash, which I guess is probably possible in actions, like at least that way we're always pointing to a specific bit of code at a specific point in time and no amount of changes to that repository if it got
Hmm.
compromised would impact us. Like that's one option. It's just a little less elegant for me as the action consumer. And so there's got to be some better way from GitHub to make it so these like high level tags are more immutable so that someone can't go hack AWS, change V1 to be something malicious now and steal all my credentials. Now that said, if Amazon gets their GitHub repository compromised, like we're all in big
Yeah,
trouble.
that's a big deal.
But I mean, in this case, this could have been solved if folks just weren't pointing to V1 and they were pointing to a specific commit hash, or if there was a more robust way to prevent that tag from getting modified after the fact. But I think, like you said, like I'm equally concerned, Corey. I think this is a an issue that's going to continue to grow, especially as like with
No, we don't have
AI
to worry about
coding.
it. Things are getting simpler, not more complex. So why worry about this? It's all getting simpler, right?
It's
There's less and less connections in the world in tech space, not more and more.
like what happens when our AI developed code starts pointing to malicious repositories and we don't know enough about anything to vet it, validate it, or whatever before we
What
check
happens
it
when
into
this
production.
happens and no one's actually coding anymore? They're all just AI prompters, which, by the
Exactly.
way, I hear is a issue. Didn't the guy just prove how, how tech companies looking for coders have these really, what are they called, leet, like coding,
Leak
uh,
code, yeah, it's a
yeah,
platform for like
questions.
testing.
Leak code is where you can find all of their fancy ass questions, but it's one of their recruiters. See if you can program a thing to design a solution to a really complex or interesting, unique problem. And some guy wrote an AI interface that would just do it for you and is not detectable while you're taking this interview on video. So even their
I hope they got the
prediction,
job.
they got a lot of virality, and they said they didn't want to work at any of the huge tech companies that use this anyways, and that's why they did it, because they wanted to work for a startup. But apparently, after all the HR managers got mad and denied them the job, some of the top people from each of these companies still approached this individual to try to hire him.
I feel
Anyways,
like they're just using the tools at their disposal for that.
he talked about college students and talking about how many of the coders don't really know how to code but are using AI to get through the classes. So I don't think this problem's going to get any easier.
Like I
If people
feel like
didn't know I was being sarcastic about things getting simpler,
yeah,
hopefully that was obvious.
I think we're in this transition period where like AI software development is like objectively going to make things
It's really
better in the
good.
short term. Like it's
Yeah.
going to help developers be more proficient or more efficient. It's
Efficient.
also going to probably let companies like use less developers, and that might cause some
Absolutely.
like layoffs for humans, but for a business perspective it'll be a benefit. But even with
But
those
long
short-term
term,
benefits, I think long term we're going to hit a point where you're not going to have enough people to debug the code that you're writing.
no new
And
code being generated by humans gives no training data to really innovate, and no humans caring to know what's happening behind the scenes means no one can fix all the problems that will very likely come up.
yeah, like
I mean, we're being a little dramatic. I'm sure there will be some people that still understand low level and coding, but it certainly is a easy button that makes a lot of people don't go the full distance.
Like just like how some old like financial systems are running on like COBOL, so COBOL
Yeah,
developers are worth like $1 million a year.
maybe
Maybe
that will be the case.
50 years from now, Python developers will be worth $50 million a year because no one knows how to write in
But
Python anymore.
out of the million Python developers today, or hundreds of millions, there will be only like 10 of the top Python developers that get paid.
Yeah. Yikes.
We'll see.
Well,
We'll see.
I'm
We
glad I
always
went
have
into
to end the
cybersecurity, which is,
podcast painting this beautiful picture of
yeah,
happiness and joy.
at least in cybersecurity, that we're totally irreplaceable by AI, right?
Yeah, there's some more sarcasm for you.
Oh man, what a future we're in.
Fun
I'm,
times. It will be good. It will be good. We can use technology to make life better. Let's just see how it goes.
or it will take over the world and it won't matter anyway. Buckle up, it's going to be fun. Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you're an AI agent listening to this, please also do the same. If you have any questions on today's topics or suggestions for future episode topics, you can reach out to us on Blue Sky. I'm at itsmark.me. Corey's at SecAdept. Corey, have you ever actually logged into Blue Sky? Or do
I
you
think
just have your
like
handle up
three
there?
times, just 3 times maybe. Is that right?
Okay,
Something
well, I
like
do
that.
get notifications, so feel free to reach out to me there. Or you can reach out to the both of us at WatchGuard_technologies on Instagram. We are very interested in your cooking recipes and pictures of pets. Thanks again for listening, and you will hear from us next week.
Bye. Hearts, hearts.